Sweden just opened a $23.5 billion financing window for new nuclear builds, enough to kickstart a new fleet of large reactors or small modular units. On paper, it's a domestic move. In practice, it could pull in Canadian uranium, Canadian engineering, and Canadian project know-how, quietly wiring the two countries into one of Europe's most consequential power shifts. Welcome to Geo Capitalist, where we decode global wealth one power shift at a time. Today we're unpacking Sweden's nuclear financing shock and why Canada could become a hidden co-architect of Northern Europe's energy backbone and Washington can't stop it. If you want to see the hidden forces shaping tomorrow's markets, subscribe and tell us in the comments, should Canada lean into this or stay focused on domestic builds first? Sweden's government has signaled it will make up to 220 million Swedish krona, roughly $23.5 billion, available as state-backed lending to companies that develop new nuclear reactors. The mechanism matters. It's not a subsidy for power prices, it's capital access to de-risk the most punishing phase of nuclear projects, the upfront build. That turns interest rate risk and construction risk from deal killers into solvable finance problems. In practical terms, it unlocks the option set. Large gigawatt-scale reactors at existing sites, like Forsmark or Ringhalls, SMR clusters near industrial loads, or a hybrid build-out, 1 or 2 big units plus distributed SMRs for flexibility. Why now? Sweden's power demand curve is rising fast. Electrification of transport, data centers, and heavy industry, including green steel, requires base load that is clean, 24/7, and scalable. Wind and hydro will carry part of the load. Firm nuclear can anchor the rest. The policy also shores up energy sovereignty. Europe's last 2 years taught a simple lesson. Resilience beats theory. Sweden wants price stability, grid stability, and investment clarity. The enabling effect goes beyond megawatts. A state lending window draws in global EPCs, engineering, procurement, construction, fuel cycle specialists, component manufacturers, and insurance. That's precisely where Canada shows up. A top-tier uranium supplier, a nuclear-licensed engineering base, and the only Western SMR project with a full utility-led build in motion today. Sweden's grid sits at the intersection of Nordic hydropower, high-capacity interconnectors, and a booming pipeline of industrial electrification. The sticking point has been firm capacity, power that's dispatchable during calm winds and peak winter demand. Nuclear provides long-duration, low-carbon baseload that plays well with wind, hydro, and batteries. It also satisfies corporate buyers with zero-emissions procurement mandates. On the demand side, 3 forces are converging. First, green steel and metals, projects that need terawatt-hours of clean, continuous supply to decarbonize furnaces and electrolyzers. Second, digital load growth. Data centers and AI clusters valuing both reliability and ESG credibility. Third, transport electrification, rail, ports, and vehicle charging that push peak shapes into winter evenings. On the supply side, Sweden retained the human capital, sites, and regulatory memory from decades of safe nuclear operation. That lowers schedule risk relative to countries starting from scratch. With state-backed lending, the investment math changes. Industrials can commit to long-term power purchase agreements, utilities can model levelized costs credibly, and financiers can tranche debt against sovereign de-risked builds. Enter Canada. Canada's operating fleet performance, its can-do heritage, its SMR program at Darlington, and its uranium leadership give Ottawa and Canadian firms a credible role, from fuel to engineering to project assurance. Sweden doesn't need a formal pact to tap that capacity. It needs bankable partners with recent real construction experience in a G7 regulatory environment. That shortlist is small, and Canada is on it. Every gigawatt year of nuclear output starts with fuel security. Canada, via producers centered in Saskatchewan, is one of the world's most important sources of uranium. For Sweden, that matters twice. First, for physical supply diversification. Second, for ESG traceability aligned with EU expectations. Canadian material can be contracted under long-term offtake structures that stabilize reactor O&M costs across decades. Beyond mined ore, there's fuel services, conversion, enrichment partnerships, and fabrication, plus used fuel stewardship and decommissioning planning. Canada's decades-long operating record equips its firms to consult on fuel management strategies that meet Nordic regulatory norms while optimizing core reload economics. Even if Sweden runs light water designs rather than heavy water CANDU, Canadian companies can still supply components, in-service inspection, steam generator services, and life extension analytics. The reliability premium is real. When off-takers, steel mills, battery material plants, or data center operators sign 10-20-year power contracts, they prize not just price but predictability. Tying Swedish nuclear operations to Canadian fuel and service capacity reduces geopolitical risk, supports EU sustainability disclosures, and creates a bilateral industrial corridor. Electrons in Sweden backed by molecules and services from Canada. This is also a capital story. Fuel security underpins debt coverage ratios and lowers the probability bands on LCOE. The more credible the fuel plan, the tighter the financing spreads. That's where Canadian supply plus Nordic operating discipline can turn a national loan window into globally competitive nuclear tariffs. Sweden's decision doesn't force a choice between large reactors and SMRs. It widens the choice set. And Canada's Darlington SMR program gives a tangible template Sweden can study, adapt, and accelerate. A utility-led, first-of-a-kind build, moving through licensing, site prep, long lead procurement, and delivery, creates procedural muscle memory that others can borrow. Why that matters? The biggest schedule killers in nuclear are front-end uncertainty and scope churn. Canada's recent experience offers playbooks for reference design discipline, modularization strategy, vendor qualification, and grid integration planning. For Sweden, an SMR cluster near industrial loads, think green steel, chemicals, or port electrification, creates a hedge against demand uncertainty while accelerating emissions cuts. Canadian firms can contribute in three ways. First, engineering owners engineer roles that transfer processes, not just parts. Second, supply chain nodes, forged components, control systems, nuclear-grade valves, inspection robotics, scaled through repeatable SMR modules. Third, operations training and digital twins that shorten ramp-up curves. The strategic upside: a Nordic-Canadian SMR bridge could standardize procurement lots, synchronize spare parts, and lower costs via learning by doing. That's how aircraft programs cut costs across fleets. Nuclear can do the same when multiple jurisdictions align designs and logistics. Sweden's lending window is the catalyst. Canada's live project experience is the accelerator. Follow the electrons. Sweden's industrial crown jewels, advanced steel, metals, battery materials, and precision manufacturing, are racing to decarbonize. Processes like DRI-EAF steel still need firm, clean power at scale. Nuclear anchors the baseload. Wind and hydro flex around it. That's the recipe heavy industry wants for bankable decarbonization. Canada slots in on the input side. Canadian miners and processors supply nickel, copper, cobalt, and graphite to European value chains. Pairing Canadian minerals with Swedish clean power yields products with lower embedded emissions, advantaged under EU carbon rules, and preferred by global OEMs. Imagine a Nordics-made cathode material with traceable Canadian feedstock and a near-zero carbon power stamp. That's a premium SKU. Then there's digital. Nordic data centers already chase 24/7 carbon-free power. SMR-adjacent campuses can reach verifiable hourly matching outcompeting geographies that rely on offset math. Ports and logistics hubs, from Gothenburg to Luleå, can electrify cranes, cold ironing, and rail with nuclear-backed reliability, turning Sweden into a green maritime node. Canada benefits through exports, joint ventures, and services. With stable Swedish baseload, Canadian companies can structure long-term supply contracts that smooth commodity cycles. Banks and export credit agencies on both sides can underwrite cross-Atlantic industrial chains, where power certainty is the competitive moat. State-backed lending is the first pillar. Project finance architecture is the second. Expect a stack of sovereign-guaranteed debt, utility equity, and industrial off-taker contracts locking in demand. That opens lanes for export credit from both sides, Sweden's instruments pairing with Export Development Canada to back Canadian equipment, services, or fuel. A credible contract for difference or regulated asset-based model can further de-risk cash flows, letting institutional investors, pension funds, infrastructure funds, insurers enter at scale. The lesson from other networks, fiber, pipelines, grids: once policy stabilizes cash flows, capital floods in. Nuclear can achieve the same with the right risk sharing. Canada's role expands here. Canadian lenders and asset managers are comfortable with long-duration infrastructure. If they can buy risk-adjusted yield on Nordic nuclear plus offtakes, you get a bilateral capital bridge, Swedish projects, Canadian money, European demand. That's how alliances become sticky, not just MOUs, but cash flow ties across decades. Finally, creditworthy off-takers matter. When green steel makers or hyperscale data tenants sign 12-20-year PPAs, they become a second anchor under the debt. Sweden's policy lowers build risk, off-takers lower revenue risk, Canada supplies fuel and services. Stack those pieces and nuclear LCOE looks far less scary. Nuclear projects fail on timelines, not physics. Sweden's advantage is institutional memory. Operating sites, experienced operators, a regulator with lived experience. Still, permitting environmental review and local consent will define the schedule. Early, transparent engagement with communities, plus clear benefits like local jobs and training, turns opposition into collaboration. Workforce is the other hinge. Reactors require nuclear-grade welders, NDE technicians, control room operators, and safety engineers. Canada's training pipelines, fed by decades of can-do operations, can help Sweden bootstrap cohorts faster. Exchange programs, apprenticeships, and twinning between Canadian and Swedish plants compress learning curves and mitigate shortages. Standardization is equally vital. Sweden's decision to expand nuclear comes with a choice: adopt reference designs, such as Gen 3 Plus reactors already licensed in Europe, or experiment with next-gen concepts like SMRs. Canada's lesson from Darlington and Pickering is clear. Avoid bespoke tinkering, lock vendor lists early, and allow modular fabrication. Standard supply chains, digital QA, and parallel work streams keep costs predictable. Then comes integration. Adding nuclear into grids dominated by wind, hydro, and rising storage requires orchestration. Advanced dispatch software, AI-based demand forecasting, and digital twins can simulate system stress before a plant comes online. Sweden already leads in smart grids, but Canada's experience in hybrid grids, blending hydro, nuclear, and growing renewables, offers case studies in stability. Another overlooked factor: financing milestones tied to regulatory approvals. Investors won't release funds without clarity on permits. Joint Canada-Sweden task forces could create regulatory sandboxes to streamline licensing. Even cultural alignment matters. How regulators and communities view risk determines how fast projects move. If Sweden manages to align policy, permitting, and people, its 220 billion crown loan framework can deliver more than concrete. It can deliver credibility that nuclear is back. If Sweden's financing window converts into concrete and steel, Northern Europe gains a low-carbon baseload spine that stabilizes power prices, attracts private capital, and de-risks EU industrial policy. For energy-intensive sectors, green steel, EV batteries, and data centers, predictable electricity pricing is as valuable as subsidies. It also reduces dependence on volatile LNG imports and limits exposure to geopolitical energy shocks. For Canada, the payoff is leverage on two levels. First, resource diplomacy. Canadian uranium miners like Cameco already supply reactors across Europe. If Sweden restarts construction, Ottawa can extend those contracts and embed Canadian nuclear fuel into Europe's long-term planning. Second, industrial diplomacy. Canadian engineering firms, component suppliers, and safety experts gain a seat at Europe's most capital-intensive projects. That ties Canadian jobs and technology into EU climate strategy well beyond LNG or raw mineral exports. Alliances harden through shared infrastructure. A Swedish reactor running on Canadian uranium and serviced by Canadian expertise becomes a 60-year partnership immune to election cycles. It anchors supply chains for European green steel and AI-driven data hubs and gives Ottawa more bargaining power when negotiating trade or regulatory frameworks with Brussels. The quiet headline, Sweden's loan book is not just about Sweden. It's a magnet for Nordic neighbors, Finland, Denmark, and the Baltics, who are watching closely. If Sweden proves the model works, Canada can replicate similar nuclear mineral energy corridors across Northern Europe. That creates a transatlantic power ecosystem where Canadian uranium, Swedish reactors, and Nordic industrial hubs form a resilient bloc. For Washington, this is a subtle shift. U.S. influence over Europe's energy mix weakens if Canada and Sweden lead on baseload nuclear. For Beijing, it's another signal that its grip on clean energy inputs is eroding. And for Ottawa, it's validation. By moving quickly, Canada can secure a front-row seat in Europe's most strategic energy build-out of the 21st century. If you found this breakdown valuable, watch our next video. It connects directly to what's unfolding. And don't forget to subscribe. Your support helps us decode these global shifts without compromise. Let us know in the comments. Should Canada lean into this or stay focused on domestic builds first? Either way, the world is watching. This was why Canada's New Deal with Sweden changes everything and Washington can't stop it. Thanks for watching, and we'll see you in the next video.